Okay, so this video is going to cover the wedge problem that you were assigned to work on in class. So this says hydraulic shears are used in manufacturing to cut large sheets of metal. Using hydraulic pressure, the machine pushes a wedge that is shaped as an inclined plane but doesn't look like an axe. So let's think about what would that look like. If it's shaped as an inclined plane, the type of wedge that we're thinking about will look something like this, right? Where the top is where we're applying the effort force, and then the force resistance would be here. Right? Okay, so this is essentially an inclined plane. It's a wedge in the shape of an inclined plane. And it tells us that the shear has a 1/4 inch thick cutting blade. Okay, so if we take a look at, if we define the different variables on this wedge here, this would be our L, right? It's the length of the slope. And then this would be our H, and then this right here is the base, right? So remember that from an inclined plane, and you can turn it around if it makes a little bit more sense to you in the shape of an inclined plane. So you could also do something like this here. Okay, and then this is, remember, your H, this is your L, and this is your X here. Okay, so this right here is essentially this just turned around. Okay, so it tells us that our H is going to equal to 1/4, all right? And then it tells us that there is a 45-degree slope here. So here's our slope, our angle, and we know that our angle is going to equal to 45 degrees between the two sides of the blade. So on this diagram, it would be here. And then a hydraulic pressure applies a 2,000-pound force to the wedge. So our FE would be 2,000 pounds, right? And then, so we know our H and we know our FE, okay? So this is what the sketch would essentially look like. So I've labeled what I know, and we need to solve for the unknowns that it's asking us to. Okay, so the first problem is, it tells us what is the length of the slope. Okay, so we don't know X and we don't know L, but it wants us to solve for the length of the slope. Okay, so that would be this value here, right? Or in this picture, it'd be this value here. So let's look at what we know. What we know is, we know H is 1/4, and we know the angle is equal to 45 degrees. So what equation that was given to you during the math review on the board could you use? Okay, so the equation that you want to use would be sine theta is equal to H over L, right? Because we know our angle and we know our H. What we're trying to solve for is the L. So if we rearrange this, it would be L is equal to H over sine theta. Or our H would be, L would be equal to 1/4 over sine of 45 degrees. So you can use your cell phone, actually. If you went into your cell phone and typed 45 and then hit sine, you would come out with the value of, I believe it would be, let me put it in my phone here. Yeah, so it should be 0.71. And then you know this is 1/4, so if you divide 1/4 by 0.71, you should come out with the L is equal to 0.357 inches. Okay? And then the last one says, what is the ideal mechanical advantage? So the ideal mechanical advantage, remember, is going to be L over H, right? So we know our L, right? Do we know our L? Our L is going to be equal to 0.357. We just solved for that. Remember? Here. And then we divide that by the H, right? And we said we knew our H, which is 1/4 or 0.25. So if you divide those two values, you should get an IMA is equal to 1.41. Right? So that's the problems for the wedge.